Hi everyone, I'm going to post a series of videos to take you through the notes we would have done in class today. Please use these to fill out your own copy of the notes and make sure you try and do the questions on your own calculator as well to make sure you're getting the same answer. We'll work more with this sine law in lecture and seminar this week as well, but you should be completing these notes before our next class. Before we get into talking about the sine law, we'll just quickly review solving right triangles. And then for the rest of this week and next, we'll be focusing on solving non-right triangles. So as a review, try this question. We have triangle ABC where C is 90 degrees, so we know it's a right triangle. And we're also given angle A and side C. We can start with a sketch. Triangle ABC where C is my 90-degree angle. Angle A is 22 degrees. And remember our labeling, across from angle A is side A, angle C, side C, angle B, side B. I also know side C, the hypotenuse, is 15.75 centimeters long. If I want to solve this triangle, it means I need to know all the angles and sides. It can be helpful to set up a table for your answers so you can see what you know and what you need to find out. So putting in that same information here. I know I need to find angle B, side A, and side B. Finding angle B is quite simple because I know two angles, and I know the sum of all angles is 180 degrees. I could just subtract the other two angles. So you can use your calculator if you like. 180 minus our 90-degree angle minus 22, and angle B is 68 degrees. We can now find side A and side B as well. And remember, we work as much using given values as possible. I can't use the Pythagorean theorem here because I only know one side, so I'll need to use the trig ratios, SOHCAHTOA. And I'll decide to label based on the angle I was given angle A, which makes this my opposite side, B is my adjacent side, and C across from the right angle is my hypotenuse. If I want to start by finding side A, that's my opposite side. And I know the hypotenuse, so I can use the sine ratio. So sine of an angle is the opposite side over the hypotenuse. Subbing in what I know, sine of 22 degrees is opposite side, which is what we're trying to find, side A, over the hypotenuse, 15.75. To get A by itself, I multiply by 15.75 on this side, so 15.75 times sine of 22 degrees equals A. And then on your calculator, make sure you're in degrees, and you can just punch that in. 15.75 sine 22 is 5.900. For A, we were told we can round sides to one decimal place. So A is 5.9. We still have to find side B. I know two sides now in my triangle, but if I want to use the Pythagorean theorem, I would need to use the unrounded value of A. It also means if I made a mistake finding that mistake carries forward. So I'm going to use a trig ratio again, this time looking at finding the adjacent side, or side B, knowing the hypotenuse. So I'll use the cos ratio. Cos of an angle is the adjacent side over the hypotenuse. So cos of 22 degrees will be side B over 15.75. I multiply by 15.75 to move it to the other side. And then I can calculate for B. So 15.75 times cos of 22 degrees is 14.603. For B, to one decimal place, 14.6. And since we were given units in the question for hypotenuse, we have the same units for the other two sides. I can check that my angles add up to 180 degrees. I can also check that across from my largest angle, the 90 degree, is my longest side. Across from the smallest angle is the smallest side. So these are some strategies we use to solve right triangles. With right triangles, we can use these trig ratios, SOHCAHTOA, and we could, depending on if we need two sides, we could use the Pythagorean theorem, c squared equals a squared plus b squared. Whoops. What we're going to focus on in the next 2 weeks are strategies we can use to solve non-right triangles. So we'll introduce that next. What we'll look at today and the rest of this week is using the sine law to solve non-right triangles. So if we keep labeling our triangle the same way, even though we don't have a right angle for triangle ABC, notice the angles are labeled with capital letters, and across from angle A is side A with a lowercase, across from angle B is side B with a lowercase, across from angle C is side C in lowercase. This labeling will hold true for all triangles. It won't necessarily be true that C is the largest angle anymore. We often had that as our right angle in the right triangles, but C isn't always the largest angle. You do need to remember when you're checking that across from the largest angle will be the longest side, and across from the smallest angle will be the smallest side. So the law of sines is set up here. Sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. When we're using the sine law, we choose a pair of those fractions to set up proportional statements, or two equal fractions, where we know 3 out of the 4 parts, the parts being the angles and the sides. Once we set that up, if we have only one unknown, we can use algebra to solve. So picking two fractions means it could look like this. We could write sine of angle A over side A equals sine of angle B over side B, or I could say sine of angle A over side A equals sine of angle C over side C, or I could say sine of angle B over side B equals sine of angle C over side C. And the choice of which pair of these fractions to use will come from what information I know and what I'm trying to find out. We can use the law of sines to solve non-right triangles in a few situations. If I know two angles and a side opposite one of them. So this setup, knowing an angle, and then a side, I can use the law of sines. If I know two angles and an included side, which is the side between them, so angle, side, angle, I can use the law of sines. And if I know two sides and an angle opposite one of them, so side, side, angle, I can use the law of sines. This last case is the ambiguous case, which we'll discuss in lecture tomorrow. Notice in all of these, I know an angle and the side opposite. Or, in this case, I can very easily figure out this angle because I can do 180 minus the other two angles. And so really, I know quite easily an angle and the opposite side. That's what we need to use the law of sines, an angle and its opposite side. That allows us to completely fill in one of these fractions, and then if we have one other unknown, we can calculate for another value. Remember, when we're calculating an unknown angle, the sum of all angles in the triangle is 180 degrees. I'll stop this video here, and in the next video, we'll start to work through some examples.